Hey guys, what's up? It's your boy Rax here, and this is a new video about how I use arenas in C and how arenas trivialize memory management. I'm going to also present my base infrastructure that I use to code game engines uh, with and without AI. So this block will be mostly focused on manual memory management using arenas. So um, most memory bugs are come from the traditional use of new in C++ or malloc, um, where you just allocate one object and then free it. And if you have many objects, then you'll have to know, like, okay, this is free, this is when should I free this, when should I free that. And lots of technologies have been built to solve these issues, like garbage collectors or resource acquisition is initialization or automatic reference counting or the borrow checker, right? And most of these technologies will have some overhead. Like, for example, if you use a garbage collector, it'll have an overhead. If you use RAII or ownership, maybe the program is efficient, but developer, you have to think about lifetimes and different, complexities with memory management, especially in C++ and Rust. So, um, as I said, you don't want to implement, uh, you don't want to allocate every single object alone. You want to group them into lifetimes. And so this is what I use for my game development, and I have not used any other type of allocator other than a pool allocator, which we will discuss at a later point. For now, arenas are very powerful, and they're very trivial. So this is the explanation. Um, I don't use malloc. I use virtual alloc, which is the Windows native arena allocation procedure, which on Linux and Mac it's called mmap, it's called memory map. And you just reserve a gigantic virtual address space. When you reserve a gigantic address space, you didn't commit it to RAM, so it's just virtual. It doesn't really exist. And once you commit it to RAM, that's where you pay the price of actually having that allocation. So, in other words, this is the simple allocation strategy. You have the base, okay, which is the beginning of the arena. And imagine this arena is infinite. Like, imagine it has 18 septillion gigabytes, okay? So you just push to allocate on the cursor, and then you just free. And that's it, right? So it's all contiguous in memory, which, the CPU loves it. The CPU will prefetch the hell out of it into the cache. You can run SIMD algorithms on it. Um, it's a nice way to lay out your code. And whereas when you allocate, like, objects separately, they have, cache misses, and it's just a rat's nest of the malloc frees. And in C++ you have that implicit free destructors and whatever, right? So anyway, I'm not saying C++ and Rust is bad, um, but I just don't use them. So, and this is the API, right? That's the entire Arena API, right? You push or you push zero. So you push the cursor and you return the here. Okay, when you push the this is your allocation. You push and you return that base address. So then, if you want to push again, you return the cursor and you move it. You move the sorry. You return the cursor address. That's your allocation, and then you bump the cursor up for the next allocation, right? So when you reset, you just go back, and that's it, right? So without a scope, right? This is how you allocate. This is a trivial example of you could call it a vec or an array. Um, so we're just allocating um, an array of I32s. And so you have the length here, which is 128, and you have the type, and that's it. So this length, I usually count it beforehand. Like 99% of the times, you already know how many elements you need. If you don't, then you either have to redesign your program or, allocate as you go, right? There are cases where you don't know how much memory you're going to need. But like 99% of the time, I know how much memory I need. So I just calculate it and allocate. And then you do. So this is how we claim the memory. And this is how we use the memory. And then this is where we clear it. But sometimes you don't want to clear it. So I'll talk about that later. This is where for when you have a scope, right? So look, I know some people are gonna say, "Oh, this is too verbose. I'm typing so much, whatever," right? So this is my arena scope, and so this is how I begin the allocation, and this is for like temporary allocations, things that I know I want to allocate and then free. Here it's for like, okay, I'm gonna allocate this, and then I'm never gonna free it. It lives for the lifetime of the program. So here is, you just get the scope. This is just saving the pointer in this temporary struct and then resets it here. And that's it, right? It's very trivial. So this is a sample, um, you know, of before you push, you get the cursor, you push it, and then it goes forward. This is how it shows you like, okay, you pushed 512 bytes, use them, then rewind, it's freed, right? It's like cheap. And this is all you need to implement an arena. Like it's just it's just a struct. And if you notice, I always pass the arena as the first parameter in all my code. So this lets you compose arenas as you go, right? And it's very explicit. It's very clear what's happening. We're not putting everything into some global allocator that magically does some free list magic and right. So the granularity of the virtual alloc and the mmap is page wise. So when you allocate a number, okay, it will allocate a page's worth of number of that number, right? So if I allocate like 6 bytes, it will allocate like 1024. If I allocate 1025, it will allocate like two 1024s, so 2048. So right, and as you go, you just reuse that memory. You just push pop, and if you push beyond a page limit, the allocator will just add a page, and that's it. Um, so this is the algorithm. I'm not going to go over it, but I will tell you that alignment is important. It's important to align your data, and I'm not going to talk about how to align, but basically, I want to align your struct based on the biggest member it has. Um, and then you commit, and then you keep going. You mutate the struct. And this is an example of how it's always passed. The arena is always passed. So this is a VAC I32 that's different from the other VAC I talked about earlier. This is a more generic type. But let's imagine that we don't have generics and you just type this. So you just pass the arena, mutate it, and that's it, right? Always passing the arena here and here. I don't know why languages love to hide this, allocator every time. They just worship the global allocator. Like only Zig, as far as I know, doesn't hide it. Um, but all others like love to hide, um, the arena. and everything follows this pattern. Um, Now this code here, it's generic, but we'll talk about that later. For now, just I'll just look at the code and imagine like it's just a normal data structure. Anyway, um, so yeah, this is the Bunyan. Bunyan just means structure in Arabic. And I have like arenas, containers, strings, build setup, everything. I'll show you how it works right now. But basically, you can build an entire game engine with this. Now, is it a triple A game engine? Probably not. You're not gonna build Unreal and Unity with this. But can you build a decent indie game engine or like AA game engine? Why not? Yeah, you can, and I have. So, and it's very simple. It's very simple because C doesn't have a lot of language baggage. It's not like C++, you have like a gigantic garbage heap of mutually exclusive ideas, quoting Ken Thompson there, but it's just a very simple language. You just have arenas and procedures, and this is how I program in assembly as well. In assembly, I just have arenas and types, and and registers, and that's it. So it's very assembly like. It's very performant. There's no overhead. There's no mental overhead for the programmer. So please check it out. I'll share the link. And so here you can see that in my game engine, for example, I this is how I structure my arenas. So based on lifetime. So for example, resources will live permanently for the entire lifetime of the program. Now, if you have a gigantic amount of resources with really a big size, this won't do it. The permanent stuff won't do it. I happen to fit the resources there, but you could fit other data in there like user data or whatever. But but I happen to like stick all the stuff in the permanent as the game resources, and it's just never freed until the end of the program. Whereas transient is just things that are going to be scratch memory. Like for example, I don't want to call malloc uh, 18 million times in a loop, right? But I can call the arena allocator 18 million times in a loop because the allocation is trivial, right? So this is my scratch memory. And the level is, as it says, it's explanatory. The level memory is, you allocate at the beginning of the level, end of the level, you deallocate and reallocate the new level, and that's it. So, yeah, this is the explanation, right? Um, yeah, I don't think I missed anything here. And you can also get creative with it. Nothing says that you should have a permanent and a transient. You could have a permanent and transient and level and enemies and AI and whatever arenas you want, Um, so yeah, so you stop asking, where, when do I free this object, right? You unlock, bulk, process, free, and mutate. So yeah, C is goated. I love C. So I mean, yeah, C is thing you love to hate. But yeah, it is quite amazing. And right, it's very clear, and you can do a lot of things with it. Like for example, here in the append, let's say I reserve the numbers vac I32 reserve 128, and then I append 1 129. So that arena that you unlocked for 128, it's no longer valid. So you just take the data, bump it up with the new reservation, copy it, and now you have a bigger global array. But I tend to avoid global arrays, um, not because of the overhead per se, but because most things I was able to solve with just ungrowable arrays. But that doesn't mean that growable arrays are not useful. But you can get a lot of mileage from like non-growable arrays. So um, yeah, and that's it. So yeah, I'm gonna show you like a bit of some magic. Yeah, this is the the repo, and this is the arena, right? So you could here, I'm gonna run it with the debugger just so you can see. Yeah. So this is my arena. I allocate it over here, and then where's the watch window? Watch. Okay, let's take this guy and memory watch. Let's put it over here, and then I'm gonna have my arena. Okay, here's my arena, right? And here's the memory view. So this arena now I initialize it. Okay, it's null. It's all zeroed out now. So once I initialize it, I have the base pointer for the arena, right? Now it's still invalid because I didn't allocate anything to it. So it's still invalid memory. Once I allocate here, this is my first allocation. Sorry, no, this is not the first allocation. This is the bookmark. I'm just bookmarking my scope. Okay, so now the scope is bookmarked, and we can look at the scope here. Okay, here's the arena location, and here's the same address that the arena has. This is the base. Now I'm going to allocate. See here, it became all zeros. Why? Because virtual alloc gives you zeros, gives you a page worth of zeros. And this is my page. You can see the page here, right? So let's go back to the base pointer. Okay. Now it's going to write stuff in the memory. You see here, it's mutating the memory. Right? So this is my allocation. It's like from here to here, I think, something like that. Right? And then boom. Here it wrote everything. This is my allocation. This is my allocation in the arena. This is my memory. And they're all neatly, tightly packed. And I use this pattern like for everything. Like, for example, let's say my game has like a vector of positions and a vector of, velocities. I just lay them all out like this in memory. Or you could like pack them up into a cache line's worth of memory, and then blaze through it with the SIMD and stuff. So yeah, I mean, that's basically it. Now you see here there are some weird headers happening and some weird comments happening here. But for now, we'll talk about that later. It's like some C hacky code gen stuff that I made. So yeah, this is the repo, and that's it. So if you have any questions, let me know. Give the repo a try, give it a shot, and let me know what happens. And hopefully you can get some good stuff out of it. Thank you so much.